in the atomic structure of atom, electromagnetic spectrum we'll see. So electromagnetic waves can have a wide variety of wavelengths that already we discussed. The entire range of wavelength only we are not telling as electromagnetic. So electromagnetic waves are a different wide variety of wavelengths, that all together wavelengths only we are calling as a electromagnetic spectrum. So the electromagnetic spectrum consists of a continuous range of wavelengths of gamma rays at the shorter wavelength to radio waves at the longer wavelength. So in the electromagnetic waves, gamma rays have shorter wavelength, and radio waves have longer wavelength. So here is telling electromagnetic waves, which one having the more wavelength, which one having the short wavelength. Short wavelength having the gamma rays, and radio waves having the more wavelength, that is a longer wavelength. But our eyes are sensitive to only to visible light. So gamma rays we can't see, because our eyes are only sensible to some only that. So one example is, what happens, one question is asking, what happens when you heat an iron rod on a flame? Do you find any change in the color on heating an iron rod? సో క్వశ్చన్ ఏమంటున్నా అంటే, ఐరన్ రాడ్ను హీట్ చేస్తున్నప్పుడు కంసాలి దగ్గర, కమ్మరి వాళ్ళ దగ్గర హీట్ చేస్తారు, ఏమవుతుంది అంటున్నాడు కలర్లో, ఐరన్ రాడ్ కలర్లో ఏమైనా చేంజెస్ అబ్జర్వ్ చేసినావా? సో వెన్ యూ హీట్ అన్ ఐరన్ రాడ్, సమ్ ఆఫ్ ద హీట్ ఎనర్జీ ఈజ్ ఎమిటెడ్ యాజ్ ద లైట్. ఎప్పుడైతే మనం హీట్ చేస్తామో కొంత హీట్ ఎనర్జీ అనేది లైట్ ఫామ్లో బయటకు వచ్చేస్తుంది. ఫస్ట్ ఇట్ టర్న్స్ రెడ్, అండ్ దెన్ as temperature rises it glows orange. When we are heating, it will comes to the red first, then again more heat given means it will change into the orange, and then yellow, and then blue, higher energy if you give means, or even white. All visible lights will come. White should come means that should give the high temperature then. So that can't possible, that's telling. So means when we are heating the iron rod, it will get the some other colors also, but wavelength, based on wavelength we are able to see only red color. We are able to see only red color. So only when the temperature is high enough, other colors also will emitted, that maybe we can see, but due to the higher intensity of one particular emitted color, that is the intensity more is the red color only. So that's why we are able to see the red color, and other colors are not possible to see that one. So maximum Planck broke with the continuous energy tradition on electromagnetic energy by assuming that the energy is always emitted in the multiples. Energy will emitted in the multiples, doubles. So for example, hV, hν, 2hν, 3hν, dash. So n hν, like this energy will releases sims. So this is the energy of certain frequency. E can be represented by the equation E is equal to hν. Energy E is equal to hν. Very important formula. E is equal to hν. Here E is the energy value, frequency of energy value, and h is the Planck's constant. Niv is the frequency. Here h is the Planck's, maximum Planck's. This is the equation, Max Planck's equation. That equation. Here constant will tell constant, Max Planck's constant. That is the value h is equal to 6. Very important. 6.626 into 10 power minus 34 joules to second. Very important value of mark question. H is equal to Max Planck's constant, 6.626 into 10 power minus 34 joule second, and here nu is the frequency of radiation or absorbed or emitted. E is equal to hν, Max Planck's equation. In that E is equal to energy, h is equal to Max Planck's constant, h value is equal to 6.626 into 10 power minus 34 joule seconds, and nu is the frequency which is absorbed by light or emitted. The energy for the red color is higher wavelength and lower wavelength is lowered compared to the energy of the blue color. So blue color energy, red color energy will compare means red color energy will be less, blue color energy will be more. That one. The energy emitted from the material of the body increases with increasing the heat energy. Suppose you are giving heat energy to any object, releasing energy also, if you are increasing giving the heat energy means releasing emitting energy also will go, so will increases more. Some heat energy you are giving, emitting energy also some will come. You are increasing some more, then here also will increases, emitting energy also will increases. So the significance of Planck's proposal that electromagnetic energy can be gained or lost in discrete values and not in a continuous manner. So electromagnetic values may comes in different manners. Sometime may increases, sometime may decreases. It may not continuous manner. That means increasing not will come, or decreasing will not come. Different manners we may get, that is telling. So hence emission or absorption of light spectrum is a collection of group of wavelength. So absorption of light spectrum or emission of light spectrum is a collection of group of wavelength. Some group of wavelength collected only we are telling as absorption of light or emission of light. So one sodium vapor lamps we will see in the street lights. Scientists found that in each element emits its own characteristic color, and these colors correspond to the certain discrete wavelengths of the light and are called the line spectra. The lines in atomic spectra can be used to identify the unknown atoms, just like fingerprints are used to identify the people. Line spectra is using to the unknown atoms. So in street lamps, sodium will be, that is why that will color in the light yellow colors, sodium. It in the previous days what it was there, but nowadays it was not there. So next, Bohr's model of an hydrogen atom will see. Bohr's model will tell about that. Bohr's model of an hydrogen atom. Bohr's model of an hydrogen atom. So what does a line spectrum tell us about the structure of an atom means? Niels Bohr explaining that or proposing that electrons in an atom occupy the stationary orbits. Electrons in an atom occupy the stationary objects. Electrons in an atom occupy the stationary orbits of a fixed energy at a different distance from the nucleus. When an electron jumps from the lower energy state to the ground energy, that is the ground state to higher energy states, it absorbs energy or emits energy when such a jump occurs from a higher energy state to lower energy state. So this is a lower energy state. This is a higher energy state. One electron jumping. Then it will, what he is telling, when it is jumped from occurs from a higher energy to lower energy state or lower energy to, it absorbs or emits the energy. It absorbs or emits the energy. Electron will get the energy. Electron will get the energy when it is taking the jumping from lower energy state to higher energy state. So energies of an electron in atom can have the only certain values. So there is a E1, E2, E3, like that values may be that one. So that is the energy is quantized here. Energy is a quantity. The states corresponding to these energies are called the stationary states. These states only are telling as the stationary states, and that orbits are also called the stationary orbits. And the lowest energy state of electron is known as the ground state. Highest, this is the ground state, you will tell. This is the higher energy state, you will tell that. So what happens when an electron gains energy? The electrons moves to higher energy level to the excited state. So what happened? Suppose here electron is there. If it will get the energy, what will happen means it will jump from one state to another state. If it will get the energy, it will jump from one state to another state. Does the electron retain the same place means? No, it will not retain at the same place. It will lose the energy after some time. Whenever it will lose energy, it will come down again. It will come down. Means higher energy state to lower energy state, it will come back. Its ground state, it will come down. The energy emitted by the electron is seen in the form of electromagnetic energy, which is emitted energy that will see in the form of the electromagnetic energy, and when the wavelength is in the visible region. If its wavelength is visible region, which is emitted light, that we can see in the electromagnetic energy, and that is called emission line. Bohr's model explains all the line spectra observed in the case of the hydrogen atom. This is only explained, Bohr's model explained on the line spectra of the hydrogen atom, and it is a successful model as far as line spectra of hydrogen atom is concerned. Line spectra hydrogen atom concerned చేసినప్పుడు మాత్రమే బోర్స్ మోడల్ అనే సక్సెస్ అయితే వచ్చింది. But the line spectrum of hydrogen atom when observed through a high resolution spectroscope appears as group of finer lines. It does not successful. It is failed. So Bohr's model failed to account for splitting of line spectra. Why that line spectra was splitted when with high resolution spectral used? That is the reason can't explain by the Bohr's model. So Bohr's model was not successful more than 2 electrons or line spectra. More line spectra is which is high resolution is used. So that's why after that this Bohr's model was modified by Sommerfeld. That only next model Bohr's Sommerfeld model that we will see in the next class.